So in this video we're going to take a look at a new type of work holding method, and that's using a faceplate. Previously we had looked at a 3-jaw self-centering chuck. As you can see, they're approximately the same diameter. The 3-jaw is probably one of the more modern and more complex and advanced, but also very convenient chucks to use, whereas the faceplate is going to be a little bit older in the technology it uses. It's really quite simple. It's just a flat chunk of metal that's threaded. And we'll look at how we attach items to this, any of our work pieces. You probably won't use this very often, but when you do need it, it is very handy, and it can be the only tool that will do the job oftentimes. Now I've got a little bit of a flaw on my faceplate. There's a little bit of a ridge or defect right here. I'm not sure the best way for you to see that or to point that out. But luckily we're going to be able to turn that off quite easily, so we're going to start off doing that. Now the faceplate mounts up just simply by threading on, similar to the way that the chuck's mounted. Now this doesn't have any holes on it to use Tommy bars to tighten it. Now in wood turning you can use a faceplate, and you can simply use adhesive to attach a workpiece to that faceplate in whatever location you may need. In metalworking, I wouldn't recommend that because the forces are a little bit more significant here. So you don't want to be using adhesive for that. You could, in theory, weld it. This piece is sacrificial, more or less. So you will end up drilling holes in this and modifying this in different manners to hold the various items that you need to hold on it. But it's a fairly cheap piece to buy additionals of, or a fairly simple piece to manufacture if you so choose to do that. As I mentioned at the beginning, I have a slight defect on my faceplate that prevents a workpiece from sitting flush. So I'm just going to quickly turn that defect off of the faceplate. If you wanted to, you could flatten out the whole thing. We'll have to see how far off it is from true. So I did just do a quick rough cut of the entire face to make sure it was flat. Isn't necessarily something you need to do, but it certainly won't hurt. And took care of that little ridge that could interfere with clamping a piece on there. I'm going to go ahead and take this off and do our next step. Now when using the faceplate to hold work, your creativity is really going to come into play here. You'll just have to experiment with different methods, and you'll be making other little fixtures and holders and ways of holding items on here. There are books dedicated to faceplate turning and work holding methods. So if that's something you really want to get into and you're really going to use this method a lot, then you can see some of the options and variations there. We're going to do a fairly simple setup, which is a workpiece with a hole through it. This makes it quite easy to secure. And I've also drilled a hole into the faceplate at a particular location. And this is what I meant by this is sacrificial, is over time you'll drill holes and slots and different methods, notches in the end to help hold pieces on here, and eventually it will become so riddled with holes that you can't put another one on. So you may end up making another faceplate or another specific type of little jig. But here all we're going to do is take a screw. This is a 1032 screw. I'd recommend you get these in a variety of lengths, as well as you can get brass and steel. No real reason for stainless steel. If you can get threaded rod, you can do that. Otherwise, you can pick up something like this and cut the head off and make it into your own threaded rod. Also, Shoreline makes a variety of clamping kits. These are designed and targeted more for the milling table, but they will work on a faceplate, and they do include some threaded rod as well as step blocks and other methods of holding items on, some T-bolts, some dished nuts and dished washers. So you can get that type of kit if you want. The problem is that the size of the faceplate, you're going to have a hard time holding a workpiece and these items on the faceplate. It's just fairly too small to use something along these lines. So again, use your creativity. I'm just going to take a 1-inch screw, put it through the faceplate, slide our workpiece on there, whichever side we want to do some modifications on. Now you can use fender washers and larger applications, lock washers, whatever you feel will help secure the piece on there. So I'm just going to do 2 nuts and I will tighten them down, and that will give us most of our directional security. If you think about this turning on the lathe, it's not going to go forward or back. It's not going to go up or down because that hole in the middle is securing it with a hard stop in this case. If the hole is a little bit larger, it would be perhaps be a friction stop, but this hole is just the right size. It's not going to go to the left because we've got that hard plate there. It's not going to go to the right because we have the washers and the nuts there. But we do have, and it's not really going to go anywhere as it spins in this axis, because again that hole is fixing it in that location. But we do have another axis, which is the workpiece itself spinning as we cut into it. So that's something we're going to have to address. So off camera I did go ahead and use a screwdriver and a wrench to tighten those down. They probably wouldn't move, but just to be sure, we're going to take an extra precaution. We do have some friction here that's holding it in place, but that friction is entirely at the center and in a fairly small area with this washer there. So we're going to take another screw, and we can use one of these existing slots this time. I'm going to put a washer on the back side because that slot is a little bit larger, just to give us a little better purchase. Then a washer on top. This could be an area where you use a lock washer or something with teeth, like a star lock washer, to give it some bite. Again, your creativity is really going to come into play here. And then we're going to tighten that down. Now we've got this area and this area all the way out at the edge that's holding that workpiece in place. So we've got a lot more rotational hold on it on the axis of the workpiece itself. I'm going to tighten this down and put on a second nut, and then we'll do some turning. Okay, so I've got this other screw tightened down on there. It's deflecting a little bit. Ideally, we would have a tube or another piece that's just slightly shorter than our workpiece in order to help even out that pressure and secure that a little bit better. But we're just going to be doing some light cuts here, and if that does come loose, it's just going to flop around. Since it is captive, it's not going to come flying off. Not a good situation, but it's not going to injure us most likely. Now, one other thing we have to make sure of is we've got all of our weight on one side of the plate here. Now, it's a fairly small workpiece and it's aluminum, so it's really not that much weight. But if we were dealing with steel and some larger work holding, then we would have to worry about putting a counterbalance on the other side of the plate in order to keep that from wobbling too much, and that'll wear your bearings early, as well as just make the operation a little more dangerous. And we have a lot of stuff sticking out here. Now, obviously, we shouldn't be putting our fingers in around here anyways when it's running, but we want to make sure and keep cognizant of that. We want to make sure that we're not going to impact our cutter. So move it around, move the cutter in, and as you can see there, we are actually beginning to impact our cutter. So we're going to have to do a push cut on this and see if that will allow us the clearance we need during the push cut. Always safety glasses. So always remember to put your safety glasses on. If you can, keep your body out of this plane so that if a workpiece were to come off, it's not going to hit you, and make sure that there are no other people in that plane. Again, with a hole, it makes it quite easy because we can make the workpiece captive. But if we were just trying to clamp this by 2 or 3 or 4 edges with nuts like this, then we would be in a much worse situation. but we do have that hole in this example, so we're going to use that. Now we're going to turn it on very slow, and let's see if we can clear it as we do a push cut. And we're not, we're just rubbing there. So in this particular setup, we would either have to modify our cutter and grind off some of the bottom, which would then weaken the cutter, or we would have to go to a different arrangement or different setup. So I've adjusted the angle of our tool here a little bit, and going to see if we can get a push cut without rubbing. And I believe we're still getting rubbing on the bottom of the tool. So what we're going to have to do in this case is actually raise the height of the tool. Again, this is just a situation where you'll have to play and mess with your setup quite a bit. This is kind of an odd setup that I've got here. If we were to say be turning down this outside edge, it could be quite a bit easier and simpler in that regard. In fact, let me go ahead and set up to do that. We'll just put a step on one edge of this. So this is an example where the work holding that I had set up really wasn't sufficient. I had mentioned the deflection of that one screw and how we needed something on the other side to kind of prop it up and give it more tension. The vibration of the interrupted cut ended up causing that to slip off. First just slip and then slip off. And so you can see we have two different steps of cuts here that we were making. Additionally, the tool that I'm using here is a little bit too thick. It's a little bit too large to be doing this operation here. We would probably have to start with a smaller boring tool. But I'm going to go ahead and switch to doing a cut on the outside of the piece instead. And I'm going to try to do it with very light and slow cuts and see if we can get by without that other work holding implement on this. See if we can get by without that other work holding implement on this side. Because I'm having some difficulty in getting that secured without doing some additional work, which, given that this is just a little demo, I don't want to make too many jigs and fixtures just for the demo purpose. So there are a few other things that we could do to help hold this better. I mentioned not using and relying on adhesive purely, but if we were to put adhesive such as what they call Turner's tape that you can pick up at woodworking stores, it's basically a strong double-sided carpet tape. That would definitely help keep this from rotating. Or we could put simply a piece of something like emery cloth or something else folded up behind it so that we get more grip between the two surfaces. But we're just going to try this rough without anything and see if it will slip. Now this is obviously going to be an interrupted cut since our workpiece is way out there on the edge. And I am taking just very light cuts because, again, I don't want to shift that workpiece if I can avoid it without needing to go to other steps. So I'm just taking very light cuts, just 2 or 3 thousandths at a time. We could do heavier cuts if we had secured this, again, like with some emery cloth or something underneath of it. Which, if this was a real workpiece, I'd highly recommend you take the time and do that, because you don't want it slipping and ruining your workpiece. So there you can see we've started to turn a step at a different diameter. And this is something that we couldn't easily do. Really, we couldn't do this in either 3-jaw or 4-jaw chuck. So using this type of either faceplate or another custom-made fixture would be the only way to accomplish that type of work on the lathe. Now, the faceplate has gone a little bit out of use because of the popularity of the mill. And a lot of the operations you would do on the faceplate can be better done on the mill, or more easily and safely done on the mill. So that's a case where we could definitely do this much simpler and easier on the mill, including the rounding, by using a rotary table on the mill, or there's a variety of setups we could do to actually get that cut on the mill. But if you only have a lathe and you do not have a mill yet in your shop, the faceplate is one of your options until you get to the point where you would have either a milling table or milling fixture for the lathe or a milling machine itself. In practical use, I've very rarely use a faceplate, and I do use it on my larger machines, but there we have a lot more clamping surface. But again, normally, today's day and age, if you've got the machines, the mill can do pretty much has replaced the majority of what the faceplate does. We will see one other use of a faceplate in a later video, and we'll get to that here coming up soon.